To Tuesday, September the 17th, homework help for Henderson and Bailey. If we look down at problem 6, we have two problems, a multiplication and a division. So let's start with the multiplication. We have 1 7/8 times 4/5. We have a mixed number and we can't have that. Either we need all fractions or all whole numbers. So what we have to do is we have to make it a mixed number. So we're going to go around. You have to do 8 times 1 is 8. The 8 plus the 7 that's already there on top is 15. So we have 15 eighths times 4/5. Okay, this is the deal, guys. You can multiply it like it is. Top times your top, so 15 times 4 and 8 times 5. But when you multiply, numbers get bigger. The bigger they are, sometimes the harder they are to handle. Well, there's a little tip is we can reduce. Keep the fractions small. 15 and 8. There's nothing that goes into 15 that can also go into 8. 4 and 5. There's nothing that goes into 4 that can also go into 5. But there's a rule here, guys. You can do any top. We can reduce any top with any bottom. So if I look at this top 15, it can't reduce with the 8, but it can reduce with the 5. 5 goes into 5 one time, and 5 goes into 15 3 times. So now that becomes a 3. Any top with any bottom again. So 4 can go into 8. So 4 goes into 4 one time, and 4 goes into 8 twice. Now the problem is once you reduce, there's a lot of scratch out. You really need to write the problem over. Okay, let's see what we have here. We need to rewrite the problem so there's not so much that we're looking at. So the new reduced numbers are 3/2, 3/2, times 1/1. Well, guys, anything times 1 is itself. That's one whole there. So anything times 1 is itself. So 3/2. Now, what do we notice about that? That's what we call the improper fraction. So we got to get rid of the improper fraction. If you forgot, what does that line always tell you to do? T-bow. Top number in, bottom number out. Okay, the way you'll see me do it is I'll just draw an arrow showing the 2 going into the 3. How many times can 2 go into 3? One whole time. You have 1 left out of 2. So 1 1/2. Now, if you don't want to reduce, it's okay. It just makes your numbers bigger and harder. In this problem, however, the numbers still remain pretty easy. The reason why the numbers are still easy because 15 times 4 is 60, and 8 times 5 is 40. We're just not always going to be that lucky because the reason why I say we're lucky is because they both end in zeros. You can cross them off, which is 6/4. And 6/4 reduces down again to 3/2. And then here we are again at the 3/2, which gives us 1 1/2. Now let's look at the second part of number 6. 12 divided by 1/6. Before we do anything, we need to change that whole number into a fraction. The best way to change the whole number of fraction is put it over 1. But before we can do that, I believe the rules your teacher gave you was KCF. We already know how to multiply. We've already done that in the first part. So that's what we want to do. We want to keep the first fraction the same. 12/1. Change. How do you change a division? We want to change it to multiplication. We already know how to do that. And flip it is exactly that. 6/1. Well, 1's as low as we can go. Top times top, bottom times bottom. 12 times 6 is 72. That's an improper fraction. That means 72 divided by 1 is 72. There we go. Okay. If now you look down at the bottom of the page, let's look at problem 9. Roger can ride his bike at an average speed of 8.5 miles per hour. At this rate, how far will he travel in 2 2/3 hours? You remember yesterday when we were talking about that these aren't math problems anymore, but let's think about them as being a story. So our story is about Roger riding his bike. So the story is about our bike here and what he does on the bike. So I'm going to set my story up in my story bar. So here I have this bike. And if I'm looking at the whole story about Roger, this is our whole story about Roger here. Roger can ride an average of 8.5 miles per hour. Well, how long in the story is his travel? He only goes 2 2/3 hour. So Roger goes at least 1 hour. Roger can go another hour. And then Roger goes part of another hour. He doesn't go the whole thing. But in his first hour, Roger's going 8.5 miles. So on his bicycle, he can cover 8.5 miles in that second hour, of that first hour. The second hour, he can also go another 8.5. And the third, well, he doesn't even go 3 hours, so he doesn't go the whole thing. Here, if we're trying to find what's missing is our total mileage that he's gone. We can either add, but we got to find part of that hour. Part of means to multiply. Not only does that mean to multiply, but what's quicker than adding all this stuff? What's quicker than adding if they're all the same is to multiply. So that's the only thing we're going to do. We're just going to take our 8.5. I can go 8.5, or Roger can go 8.5. 8.5 miles times 2 2/3 hours. Now, once I have this based on my story, now I've got to get rid of the mixed numbers. I got to make them improper fraction. Remember, you're going to go around. So we multiply by the whole number. 2 times 8 is 16. 16 plus the one that's already there. So 16 plus 1 is 17 divided by 2. Times, go around here. So 2 times 3 is 6. And 6 plus 2 is 8. Okay. Remember, with fractions, you want to reduce them because you only want to keep them small. Because when you multiply, it's just going to make them bigger. 17 halves cannot be reduced. Neither can 8 thirds. But remember, you can do any top with any top with any bottom. So 17 and 3 cannot be reduced. But what about 2 and 8? They're both even, so we can cut them in half. What's half of 2? 1. What's half of 8? 4. So now when I look at the problem, I have 17 times 4. So I got to do my 17 times 4. 4 times 7 is 28. Carry my 2. That's 4, 5, 6, 68. Divided by 3. That's an improper fraction. So this one I probably need to set it up. It's too hard to do in our heads. So we have 68 divided by 3. 3 goes into 6 twice. That's 6. I have nothing left over. Bring down my 8. 3 goes into 8 twice. Just 6. And I have 2 left over. So my answer is 22. And look, I had 2 left out of 3. You always put your remainder over what you're dividing by. So 22 and 2/3. So Roger rides 22 and 2/3 miles in 2 and 2/3 hours. I'll see you again tomorrow night.